All right, guys, I'm on page 2 now. I'm going to go ahead and go to page 2. And on page 2, problem 13. Problem 13. Take 1 minute to yourself and think about this question. So let's read the instructions. Consider the 6 data sets below, which are linear, which are exponential. And for all exponential, come up with the equation. I want you to think for a minute on your own. How do you know, beyond a shadow of a doubt, that f of x is exponential and g of x is linear? How do you know beyond a shadow of a doubt that f of x is exponential and g of x is linear? Think for a minute on your own. Comparing f of x and g of x. G of x has to be linear. How do I know this? How do I know this beyond a shadow of a doubt? You've got a minute to think about it, so some thoughts. How do we know for sure? How do we know for sure that g of x must be linear? How do we know for sure g of x must be linear? What did you guys learn for the definition of a linear function? Oh, Kurt taught you better than this. We know this. What does it mean for a function to be linear? I think Christian Rugamos knows. He's just not keen to share, so we'll extract it out of him. Christian? Oh, no, G. Right. There's, keep going. Right, so every time x goes up by 3, y is plus 7. In other words, the more kind of mathematical way of saying this is that there's a constant slope. G of x has a constant slope. Any linear function must have a constant slope. F of x, on the other hand, does not have a constant slope. Here I went up by 5, now I randomly went up by 10, and I went up here by 1 and here by 1. Something is going on here. This is not linear. Norma?
Oh, doesn't it have the y-intercept at 0?
Which one? The f?
Yeah.
That's right. That's right. So now, we know this is exponential. We need to write the equation. The equation says y equals a times b to the x power. Always, start by plugging in the y-intercept. Start by plugging 0 here. It's the best option. So y equals a times b to the 0 power. But y, when x is 0, y is 5. So 5 equals a times b to the 0 power is 1. So 5 equals a. Plus unit. 5 equals a. Now I'm going to say, okay, 5b to the x. 5b to the x. Well, I could plug in 1 for x, and I must get 10 for y. I could plug in 1 for x, and I must get 10 for y. So 10 must equal 5 times b to the first power. Divide both sides by 5. 2 equals b to the first power. So what number raised to the first power equals 2?
2.
Must be 2. 2 raised to the first power is 2. So b equals 2. So I've got a, got b. So now I know the equation of this function is y equals 5 times 2 to the x power. And now, I'm in a really good position to find k. I can plug in 3 for x, and I'll get k for y. So y equals 5 times 2 cubed. Plug in 3 for x, I must get k. 2 cubed is 8, so y equals 5 times 8. Y must be 40. So the k value equals 40. Matthew?
So like in the beginning, we just have
Here or here? Sorry.
over there.
Right here, okay.
So when you have 5b to the x power,
Mhm.
where do you get the 10? Okay.
I'm gonna pick any point. I just picked the easiest one for me, which is 1 to 10. Does that make sense? Great question. Javier?
When we have an equation like that, I mean,
Like
just
this?
charts, when we just have charts, how do you figure it out it was y equals AB to the exponent?
Because all exponential equations look like this. Any exponential equation is a times b to the x power.
And then we just plug in any point before x, and then we do the
Yeah, I would start with the y-intercept first because that's easiest to get a. Yep. Questions? All right, Lucia, we can stop this one.